Hello everyone, thank you for joining us today on our product and technology showcase webinar. These are 20 to 30 minute webinars that we showcase some of our 3D scanning hardware, software, and 3D printers. Today is the webinar for the Artec Micro. So the Artec Micro is a high accuracy 3D scanner, kind of geared for our smaller parts. It's a desktop unit. As you can see, we have a small part on here. It's a turbine blade. And today in the webinar, what we're going to show is the scanning process and final output of the file. So let's go ahead and bring up Artec Studio and we'll go ahead and start scanning. All right, so this is Artec Studio and we're scanning here with the Micro. This is all the nice user interface that Artec Studio has to provide. It's a real nice and clean, simple process for scanning with the Micro. Basically, you'll see the part here that we're scanning. Below that, we have scanning paths. So we do actually have some different options for creating different scan data from different size parts. So we can do just basically a small normal path here. We have capturing single frames or some defaults. So if the part is large, if it's complex, normal, or simple. Small objects like this, again, complex, normal, or simple. So the complex files section will actually provide us more scanning area, so it does take a little longer. And then we also have our normal, which is basic, and then simple. So if you're just doing something that maybe has less undercuts in this part, you might go simple. Let's go ahead and set up on this some normal. And then we can set this up if we wanted to do something with high resolution. Also, if we wanted to capture some color. So let's go ahead and do some high resolution scans on this. So what the scanner does is it actually projects a pattern onto the surface. And based off of the distortion of the pattern, the cameras will use that to take pictures and align each scan to each other. The scanner has a 2-axis turntable, so the whole scanning process is really automated, which is really nice. So with the complex setting, the scanner will capture 44 frames here, and it'll give us a progress bar while we're going through everything. The stated accuracy of the scanner is going to be plus or minus 10 micron, and stated resolution is going to be 30 micron. So accuracy 10 micron, 0.01 millimeter, and resolution 0.03 millimeter. We get asked a lot, well, what's the difference between accuracy and resolution? So accuracy is repeatability. When we state the 10 micron accuracy, this is a repeatability for us. So typically we go through a process where one person scans the part a certain amount of times, and then we pass that along to a few other people. It could be 3, 5 other scan technicians, and then we take the data from each of those scans from each of the scan technicians, and then we do an inspection, or we do, let's say, an average of accuracy between those scans, and that will provide us what the stated accuracy typically is from the manufacturer. The resolution is actually the point spacing. So when we're scanning this, the resolution at 30 micron or 0.03 millimeters means that within 0.03 millimeters, we're going to have a point, point to point. So there could be some a little bit more, but typically that average out at 0.03 millimeter resolution. Each one of those points has an X, Y, Z coordinate system, so it knows where it is in space. And that's how we kind of have the ability to create the mesh and connect those points by triangles, is because of those point spacing and the X, Y, Z coordinate systems. All right. So for our first scan that we have here, took 44 pictures or frames, and this is just the point cloud from the data. Of course, we haven't scanned the bottom, so let's go ahead and pull this off. To attach this, actually, I just went ahead and used some putty or museum putty, and then we just attached it to the bottom of this. So let's go ahead and take some of this off. You'll notice here that there's some female screw fixtures. So the system comes with some fixtures that we can actually use to mount the part if it's a little bit heavier. So for instance, this valve might be a little bit heavy for the putty to hold, but for this part, it's a pretty light part, so we can just go ahead and use this putty. I'm gonna go here, and let's go and scan this again. This time, I'm actually just gonna go ahead and just do a small, simple. We're just trying to capture that bottom area. We don't need the high resolution because we're trying to capture this, and we'll go ahead and scan on it. So what you'll notice here, last time when we scanned, it gave us 44 frames. So here we're actually only going to do 28 frames. What you'll also notice is that this scanner is a desktop system, really easy to move if you need to. You need to put it right next to your computer. It's great for scanning. It is designed for scanning smaller parts, right? So you see in here we have like this valve here. We do a lot of stuff with dental implants. We could do these are like small. I think this is like a rat skull, small 3D printed parts, things like that. That's kind of where the ideal space or part size for scanning these objects. Now, if you're trying to scan something larger, so we have a lot of clients looking to scan some skulls or bones for archaeology, anthropology type stuff like this. This might not be the ideal size for the object. We still can do it. So if you wanted to get some small detail, high detail within this area, we can set this in and scan it. Remember here, we can also create some paths so we can scan it from one side just to get some high detail. And then we could take maybe some space spider data, scan the part, and combine those. So maybe we'll do another webinar on how to combine the data from the Artec Micro and the space spider for parts like this. All right, so we're just coming up and looks like we're all finished. So now we have 2 scans here. You'll notice that they both do have different frames, amounts, and they're not aligned. So we have our scan 1 here, which is our blue one, and we can identify that as here. And if we switch them around, we have this more pink or color for the bottom. So let's go ahead and click out of here. So the first thing we're going to do here is I'm going to actually delete some of this table area that we don't need. So let's go ahead and just clear some of that out. So I'm going to go into my editing tool in the eraser tool. With the eraser tool, we have a lot of functionality here. We have a 2D eraser here that we can kind of erase out through here. This is a nice tool. We also have one of my favorite ones, which is the lasso. Oh, sorry, that's the rectangle one. So rectangle, we can kind of just delete out of here. We also have a lasso tool. We can just kind of lasso around areas. And delete. And let's go ahead and delete all this out of here. Erase it. And let's just double check on that other one, see how much we have out. All right, so same as here, we'll just go ahead and do this. For this part, I'm just going to go ahead and use that rectangle. And delete it. It's okay that we're deleting some of this data. We have it on the bottom side, so most of this we're just actually using for as reference for when we can align these scans. So once we're done with deleting out of this, what I want to do is actually do a registration. What the registration does is it's going to do a best fit for each of the scans. And of course, in a webinar, things happen, so this is a little delayed, but no problem. Let me go ahead and show both scans here. So software actually does a fine registration on each individual scans from the micro, so it's grayed out. We don't have to do that. So the next thing we'll do is we'll just go ahead and align these scans. So we do have an auto align tool, which is really nice. It just automatically aligns the scans for us. I'm just going to go ahead and show you this another tool. It's called I call it a pinpoint alignment. And what we're doing here is just taking a couple common points on each part of the scan. And what we're doing here is actually just helping the software do a quick alignment. I know there's a spot right here for each of them, and maybe one more. Typically, you need about 2 or 3. We maybe don't need as many as here. I'm just going to align that in. So it got to where these points were close to where I put them, but as you can see, the data is not aligned, and that's no problem. This actually is just for getting it into a general area, and then we're going to click Align, which allows the software now to use the common geometry that we have to do the alignment. We also have an ability to use texture alignment, so using color. So if you are scanning something that has a lot of color, we can actually utilize that tool to do the alignment. All right, so it looks nice and aligned. I did notice that there's some data here from left over that I didn't clear out. So let's just go ahead and hit apply, and I can see it's coming from the blue selection. So let me just go ahead and clear that out first. little more right in here. And erase. All right, so now we have both scans here. We did the alignment process. So I'm just going to click out of here. So once we're done here, now that we have these both aligned, what I want to do is actually I want to go ahead and do a global registration. So I'm going to go into my tools here, tools section, after I click out of there, and I'm going to do a global registration. Just going to use the geometry because we have no texture. But if we did apply the texture when we're scanning, we'd have an option for texture here, and I'm going to hit apply. So what global registration does is it looks at these individual scans and does a best fit between the two. So automatically when we're scanning, the software will do a rough registration, which you'll see on the top under the registration. That's aligning all the scans together. And then once we're done, the software automatically did the fine registration. We can use that later in a different scanner. Artec has the Micro. They also have the EVA, Space Spider, Leo, and Ray. So we do have the ability to use that fine registration in that software as well. So Artec Micro does collect a lot of data. So you'll notice here it just takes a little while to do this registration because there is a lot of points that we're taking into effect. You'll also notice in our workspace here, the two scans, the difference between the amount of data we collected versus the simple versus the high resolution complex. So pretty good size difference here on the files. All right, so we went ahead and did the global registration. Everything looks really good on this side. And now I'm just going to go ahead and do our Sharp Fusion. So I'm going to go ahead and do a drop-down menu on the Sharp Fusion. Under Sharp Fusion, basically, we have a default resolution set at 0.7. We can actually increase the resolution if we like by lowering this number. I'm going to stick to defaults on a lot of this stuff. Don't want to play around too much with some of the settings here for the webinar, but if you have questions, we can definitely set up a separate time to do another web demo. We can go into that process. Artec Studio has a lot of parameters that you can work inside besides going through default settings. So those are kind of next level things. We also have an autopilot. I don't know if you guys got to see our last webinar that was last week, but we talked about autopilot, and it's basically an automation process that I'm going through right now. It kind of takes care of all the steps in this process that I'm showing in this webinar. If you didn't get to jump on that, just let us know. We do have links onto our YouTube that we recorded and putting it on there. Also, we're going to record this, so if you did want to share it with any of your coworkers, friends, family, you can definitely send that link. And yes, we're still here. Artec Studio is just computing some of this information. When you do scan with that complex shape, it does collect a lot of data. So processing the data can take a little time. Just to let you know, this is a off-the-shelf Dell computer, so it's the XP15. It does have 32 gigs of RAM. It's the i9, has a solid state drive, so it is a pretty strong computer. But there are options out there to get a stronger computer, which will process the data a lot faster. All right, so we're almost done here. As you can see by the little green progress bar. All right, and here's our file. Full 360 here of the parts. We do have some outline data here. As you can see, we have a really cool feature here called Small Objects Filter. Click of a button, and it deletes it all out. So Artec Micro, excellent, as you can see, for scanning parts like this. Really high detail. As you can see, we have so much detail that I forgot to remove some of the putty here. So that's being shown inside here. Also, there is a nice chip within this turbine right here, this little blade. So we can see the high resolution of that. I think on one side, yeah, here's some of the markings on the part. You can see from here. So this is just a quick webinar. We wanted to show you the Artec Micro, the process. We do have a lot of clients in the automotive industry, aerospace, manufacturing that are looking to scan small objects that need high resolution, like this little turbo blade. So this is an excellent scanner for this purpose. I think we will set up another webinar with one of our application engineers showing the reverse engineering side of this part. So if you have an existing part, how do you reverse engineer it and create a CAD ready model for manufacturing? So hopefully we'll set that up pretty soon. But we'll make sure that that webinar gets posted to all our social media, as well as our monthly email blasts that go out to everyone. If you don't see them, please contact us and let us know. We'll definitely set you up to receive those emails. Typically what we're going to be doing is every week we'll have one of these product and technology showcase webinars to show one of our scanners, one of the softwares that we use like Geomagic, or one of our 3D printers. We'll also dive into the actual software of Artec Studio, Geomagic Design X, Control X, and start showing some of the tools and features within the software, which are great to know, or if you are a current user, it's a good training or refresher. So I want to thank you all for joining our webinar this morning or this afternoon if you're on the East Coast. If you have any questions, feel free to give us a call, give us an email. Just going to drop up the contact information here. So any questions, definitely reach out to us. Again, thank you very much, and we look forward to talking to you. Thanks.